Hello and welcome, dear viewer. Today I thought I'd do some more Serenity hacking, and actually something that I wanted to implement for some time now is Unicode display in the HexEditor value inspector. So I think Tim, added a HexEditor value inspector recently. Let's see. The Serenity GitHub should be a closed PR or it should be a merged PR. Let's search for value inspector. Very, very well prepared. Yeah. So you can see here that he added this sidebar which displays values in the that you've selected in the hex editor, and for example that allows you to see what, for example, these 4 bytes would be as a signed integer. Like this would be this would be 64 bits integer, so I could see down here, for example, and float and double also, for example, which is really nice. If you're looking at binary files that contain floats and doubles, it's not at all obvious, even if you can guess the size of the int through the hex pattern. So what I asked him about is, I think I asked him about if he couldn't add Unicode stuff, so that you could select 1 or 2 bytes. It would tell you what this would be if it were interpreted as a UTF-8 byte or UTF-8 sequence, code point sequence, because of course a single Unicode character can span multiple bytes in UTF-8. And he didn't add that, but yeah, he was interested in the feature. He didn't add it because maybe it was too difficult, or maybe he wanted to keep the scope of the PR smaller. I don't remember. Anyways, it's now the value inspector infrastructure is now in the system, so I can now go and implement it. I've actually been meaning to do this for some time now, so yeah, let's actually check which files this affects, and the sidebar for some reason doesn't appear. That's HexEditor. Is there a new widget for that? Value inspector model. Oh yeah, okay, so we need to value inspector model. And good thing that I recently worked with models, so I have some understanding of how model indices and models work in Serenity. It's somewhat of a difficult system to understand. I think we should write some documentation on how that works. But yeah, anyways, so yeah, I think let's start by just adding things in here. So I'll start with ASCII. Of course, that's of course also important, just to have an ASCII view of the character, even though you have the second column. If we go back here, you have this second column which shows you all the things in ASCII. I think it's still valuable to have ASCII display. Then let's have UTF-8, and maybe let's add, or let's start with UTF-8 for now. I don't think we have an easy way of converting something to a UTF-16 character thing, whatever. That would be really convenient, but for UTF-8 we definitely have some support already, converting from and to UTF-8 and looking if the code point is valid and so on. So that should be easier. So yeah, and ASCII of course is rather trivial. So let's add the name of that. So what's that? ASCII, return ASCII, and UTF-8 return. Also, let me actually increase the font size. I got some complaints on recent videos. Return UTF-8. Okay. Okay, data. No, yeah. Okay, let's fill out the data. Now the custom role tells us the width. So this is 1 for ASCII, and it's 1 to 4 for UTF-8. Now that's hard. Let's yeah, that's difficult because this doesn't support variable sized value inspectors for now, I think. Let's put a fix me in here. Can't even type. Fix me. UTF-8 is variable size. Okay, and now that's the header. And let's see. That's actually really simple. I'm thinking about why this is in the header. I guess we could move this to a CPP file if we wanted to make things cleaner, because now I have to recompile a bunch of stuff just because I touched the header, even though, yeah, this is the only thing I would have to change in the header. Anyways, so let's find all references and see that's in the HexEditor widget. So we have set parsed value. Where's that? That's update inspector values. Yeah, that looks like the correct one. So of course I reviewed that PR, so I have some basic idea of how we implemented stuff, but I haven't, like, it's been a couple weeks since the thing got through and since I did the review, so I need to page that into mental working memory essentially. Okay, so yeah, so I guess we get a unsigned 64-bit int, which is, yeah, okay, now we have to check. So little endian. So this is now in the host endian, as I'm thinking, because it should, if we properly convert little and big endian here, we should have the, for big endian, we're shifting over each time. Yeah, so for big endian, we should have, I'm just thinking which one of the bytes in the 64-bit integer is the first one. Oh no, I guess I'll just have to read like from the topmost, from the most significant byte, topmost, yeah, in the sense that it's the furthest to the left, yeah, the most significant one. And so for little endian, the most significant one in host endian will actually be the right one. I can never remember which way this goes. And for big endian, the actual most significant bit, like the leftmost most significant byte, the leftmost byte, will actually be the one that is the furthest left in my visual selection in the hex editor. So let's actually just implement something that I think is right, and then see whether that's correct. Should be rather simple to check with some basic multi-byte UTF-8 sequences. Yeah, so byte read count greater than 1. Now I'm asking myself actually right now all the time where the data is used. Let's search for data. Set selection. So value inspector on activation. Then we increment. Okay. So if we select, if we click something in this, let's go back to the image. If we click something on the right here, I hope you can see my cursor, we actually increment or decrement the selection accordingly, which of course is a great feature, and a bunch of hex editors are missing that. Now, yeah, so I need to actually look at the UTF-8 value that I have in order to look up how many bytes I need to select. So yeah, so select the type. Do I actually have like the value? M values, oh, here we go. M values at no. That's that returns a string. There's M values. Oh yes, so that's the actual thing that we're storing, which would be a string containing a number, or in our case, an actual UTF-8 string. So I think we can just look up. How for M values at index.row, we can just look up how many how many bytes that takes in UTF-8, and do that. Yeah, okay, fantastic. And that would give us a 0 if the string is empty. Yeah, that's okay. That's completely fine. So I don't actually know how C++ or we with AK-string handles UTF-8. If I specify size, is that the size in bytes or the number of code points, which of course can be less than that. So there is, no, that's bytes. Characters, length, impl length, the string implementation, the length, size t, length, inline buffer, or the pointer or something. Where's the pointer actually? Is that a virtual class? No, it's not. K-free sized. Okay, so the length is actually the size in bytes. Which is not the greatest idea in the world, generally speaking. No, it's actually like, it's a terrible idea. There's a reason why Rust doesn't do this. But I guess that's just C++ baggage. Because like UTF-8 individual sequence values, which have like this starting thing at the top with like unary specifying how many bytes you need to read for the single code point and so on. That's like completely, yeah, that just doesn't make sense. If you have like a continuation byte in UTF-8, that thing individually has no meaning. It needs like the entire code point, which can be spread across multiple bytes. Okay. So let's see, I saw the UTF-8 view here. I don't even know what that does. Okay, so underlying code point length in bytes. These methods return the information about the underlying UTF-8 bytes. If the UTF-8 string encoding is not valid, might be different. Code relies on the code characters, blah, 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 blah. UTF-8 view validate. Okay, so it looks like UTF-8 code point, UTF-8 view is a bit more, is a bit more, doing things a bit more correctly. Code point this. What does the increment up here do, by the way? Let's see. Operator, Unicode code point iterator, operator plus plus. It should be somewhere up here. Offset of Unicode substring the code first, validates. Blah blah. Where's the? Oh yeah. Okay. So this will actually look at the underlying code points and see if I saw that up here somewhere, and actually, yeah, look at how many bytes follows and whatever the matter is. Yeah, fantastic. I think we have to UTF-8 view the entire thing, and then. Yeah, okay, so let's case UTF-8. Maybe that's why Tim didn't do that. So let's start with a equals values index or .add, which I guess does the same thing. At index row dot is there something like, no, let's use a UTF-8 view. We already do that somewhere. I can't remember. This import looks very pointless here. Okay. Of this. Can we do that? Guess so. Yeah, it's constructible with a string, so it even takes a view, so there's no copying involved. That's fantastic. So this should actually be rather cheap, except for us checking like the code points and stuff. So UTF-8 view dot validate. Have to like what does that do? Yeah, it just tells me if it's valid, I think. Yeah, so if it's valid, then we continue, otherwise we just return 0. Because then we have an invalid code point. Like for example, we're starting in the middle of a sequence, something. So in that case, we can actually return UTF-8 view dot length. Yeah, and it has a separate function for byte length, whatever that is. Cannot jump from switch statement. Jump bypasses variable initial. Well, I think we need to do this. Yeah, okay. So, so if we have something valid, then we can actually just return the view length. So that was the one that was doing the calculate length. Yeah, so on calculate length probably verifies that it's, or like it would crash if it's not valid. Either way, we validate that first and then use 0 as a safe fallback. Okay, I think that actually solves like the auto sizing for us. And I actually saw that there's a UTF-16 view, so I think it shouldn't be too hard to do things for UTF-16, but let's stick to UTF-8 for now. So let's see the update again. Where's the update? Update inspector values. So down here we have byte and unsigned byte. So I think we can just value inspector model set parsed value. Value inspector model value type ASCII string dot. It's probably something like from. There must be an ASCII constructor like from bytes or something. Or maybe I just want to convert char because char should just be ASCII, right? I think so. At least like in C++. Only bytes. Yeah, I can construct that from bytes. So I want to use repeated actually. It's maybe the easiest. So I want to static cast char the signed byte value and repeat that once. Yeah. And I think even U8 might even be the same type as char. I don't even know. Like, no, I think it's actually I8 should be the same as char. Anyways, doesn't really matter. Okay. So we do that. Otherwise, of course, we have to set an empty string. Okay. Now we need separate validation for UTF-8. So basically what we want to do is like start from the like try and for this. So definitely UTF-8 can't contain more than 4. I think 4 might be the most number of bytes a single code point can take up in UTF-8, at least like the limited form of UTF-8, because in theory the maximum size of unary, the maximum unary you can use is all ones or 7 ones and a 0, which would indicate either 8 or 7 bytes of data for that code point, if I remember that correctly. And that's the form of UTF-8, like the unbounded maximum form of UTF-8, theoretical maximum form of UTF-8 that flag uses in some of its variant header data information thingies, whatever. I wrote a separate UTF-8 parser just for that, because that specifically uses the unlimited form and not like the limited form that is enough for Unicode, but not enough for some of the larger values that flag might require. I think for like some specific sample sizes or sample counts or something like that. I don't actually remember that specifically. It's not a feature commonly used in flag either. So like the bounded form of UTF-8 should only consume something like 8 bytes, because I remember like UTF-8 itself can at maximum like contain something like 3 bytes of like a code point. The maximum code point is something like 3 bytes long. So you might need 4 bytes because of all of the signaling bits at the top end of the bytes. So let's actually go with that. So what I'm thinking to do here is to because we're reading an arbitrary amount. We're always reading 8 bytes, no matter how large our selection actually is. as far as I can tell. Yeah, or sometimes we might not read that far, but what we can do is we can try and parse a UTF-8 code point, a single one. And if we're reading, if we need more data than is available for having a valid code point, we can just not print the UTF-8 value. I was just thinking that maybe the byte read count is limited by the selection size, but I guess it's actually not limited by that. Yeah. ASCII, UTF-8, UTF-16 timestamp. That's a great idea, Unix timestamp. But yeah, let's put that down here. So ASCII, we can already remove ASCII from the list because ASCII is just a byte. That's rather simple. So let's actually try and let's create a short little byte buffer out of these 8 bytes. So or something, yeah. Let's do that actually. Byte buffer, read only bytes. I think it's a span, u8. Byte buffer, which should be constructible with like, is that not constructible with a initializer list? What's that? Bytes, or can I just create a bytes span over over a stack local? I think I can just do that. I can just take the let's just do some like pointer shenanigans here. I can just take the unsigned U64-bit int. Okay, so bytes, I don't know, equals span of reinterpret cast to a U8 pointer, the bytes, or even read-only bytes, I think. The unsigned 64-bit int. What does that tell me? Where's the read-only bytes again? Read-only bytes. Yeah, okay. That's a span of U8. Oh, and span needs span constructor, please. Span constructor, please. There's no span constructor for this stuff. How do I do this without allocating more memory? I think there's some way of doing that. Wait, here we go. U8 const pointer. Oh, I need a size. Okay. Let me actually const that, and then for let's have only bytes with that. There we go. From const U8. Wait, no. Expression result unused. Yeah. Oh wait. Wrong brackets. Wrong brackets. Yeah, fantastic. Okay. So that should not. Now endianness is a problem. Like the first byte should be the most significant one. Fix me. This probably doesn't honor endianness. Anyways, let's just it's actually UTF-8 view of bytes. Please get rid of that import. Maybe I'll actually just combine that into one massive initializer, because there's really nothing to worry about here. Yeah. Okay. We have the UTF-8 view now, so if okay. Dot begin should be a code point iterator. Yeah, okay. So I think we want to now the problem is that like I want to get the first UTF-8 code point in this byte sequence or none. I don't want it to crash if there's none, of course. Let's see how we could do that. Because begin probably, let's look at that iterator. No, actually operator. Okay, I think the constructor doesn't verify actually. It doesn't verify anything. Where's the ++ verify length, underline code point length? No, underline code point length. If okay, so if the first byte doesn't make sense, then we just that's just a fantastic name. Like unironically, absolutely unironically, first byte makes sense. That's a fantastic name. If the first byte doesn't make sense, return 1, which means we just advance by 1. Okay, but yeah, so we get, oh, what is the operator star? It's a U32. Underlying code point length in bytes. Underlying code point bytes, which will probably also check the, yeah, so that checks stuff. So like, do I have a simple way of like verifying that the thing even makes sense? I don't see it right now. Because is valid checks the entire string. Like validate. Valid bytes. So no. Validate. Oh, validate has an out parameter that tells me how many bytes are valid. Okay, that is super useful. Validate. So let's have a, what is that? Size t valid bytes. The valid bytes, please. So let's not have an if right up here. So let's just validate if valid bytes is equal to 0, then we want to value inspector model set parsed value for the inspector model value type UTF-8 nothing. Or maybe actually let's just for now put in invalid or angle brackets, maybe that it's clearer. Okay. What does this do? Requires 0 arguments, but 1 was provided. Excuse me. Isn't that public? UTF-8 view. Okay. Oh, that's a reference actually. Oops, so I don't need the address here. Okay. Valid bytes is 0. Then we set invalid. Okay. So otherwise, value inspector model set parsed value still the value inspector model type UTF-8. No, UTF-8. Now the string value is the first code point. So that's UTF-8 view. Substring view, actually triangular function, or that's just a byte length. Oh, I actually know the length. Yeah. Unicode. Oh no, I can use Unicode substring view, so I can say 0,1 there. String view 0,1, and then probably like something like as string. Then I get a string view out that just converts to a string nicely, or does it even need? Yeah, it needs a string, but yeah. Well, we'll do a copy here, but that's absolutely fine. Like, this is something that only gets run when the user clicks somewhere, so I think that's fine. So let's actually remove UTF-8 from the comment as well. So, and actually let's take that, put that at the very end. Okay, let's try this, and let's hope that I don't get a full rebuild, which I guess I don't. Like, I built before starting the recording, and I mistyped my password. I built before starting the recording, took like 15 minutes because somebody touched some much included header. Happens frequently, of course, but it's always kind of annoying when you see, oh, it's only 100 commits or something that I need to download, and it's still boom. Okay, so let's open up the text editor and create some non-ASCII text. This is a file with non-ASCII characters. I'm going to write a nonsense German sentence now. don't try and understand what this sentence means. It's literally, it's a lot of nonsense, but it contains a bunch of non-ASCII characters. I could have also just used my hovercraft is full of eels in I don't know, Klingon or something, because those characters will like even have more bytes, because I know that like these German accent characters are just 2 bytes in UTF-8 because they have rather low code points. They're in one of the first Latin extended pages. Okay, so UTF-8 test txt. Okay, now let's open up the hex editor. So in here under development, file, open the UTF-8 test. Nope. That's okay. Well, that's weird, but it doesn't have to do anything. Yeah. So for example, here you can see these UTF-8 characters here. Oh yeah. So let's enable the value inspector. Yeah, first byte doesn't make sense. That's fine. We now go into... that's correct. That's correct. That's an... Okay, we crashed when clicking on that, which is probably related to us not handling types properly. Activate selected. Callable wrapper, HexEditor widget, call model index. It's just not 57. SI32. Data custom. Yeah. Okay, so what we need to actually fix is that we get a fuckton of printout here due to us not having correct Unicode characters, which in this instance is absolutely fine. Now, yeah, that's so we need to. So the index data. But the first problem is that we're not returning. Apparently, we're not returning I32. Something U32 can be converted to that. That's kind of sus, to be honest. Anyways, first of all, not. Yeah, okay. Or let's actually put this behind a flag. UTF-8 debug. Okay. So all debug macros, we need new debug macro, ut set UTF on, and then we need debug.h for, not for the kernel, but in AK. Debug Okay, that's the first order of stopping the absolutely unnecessary spam. Okay, didn't I? There's some debug file that I missed. Did I miss the debug flags for lagom? Let's just force it to recompile. Not liking it. Not liking it. Let's search for URL parser debug where that is used. It's in maybe I just need to include debug.h. Wait. Okay, I just need to include debug.h so that I get the let's do that actually, yeah. I think I'm not even changing the header, so this should be a not super slow compile. Yeah, so it's just this is all very much cached. So it's gonna look like a full rebuild or like a half system rebuild, and it's gonna stop on file.io, but it's, you can see Ccache handles most of that. Yeah, absolutely. Okay, let's quickly commit that before I forget, and let's actually check for debug. Yeah, okay. So we need a couple more. Okay, that's all of them. At least I hope so. Yeah, so save that and see how the build is doing. UTF-8. Should like please save that? Yeah, it's absolutely pegging the hard drive. Debug any. Okay, it's gonna do that again. It's not gonna like that either, but yeah, the build works, so nothing surprising, but let's wait for stuff to actually work here. AK put UTF-8 invalid UTF-8 debug spam behind a flag. This is very annoying if we're intentionally passing invalid UTF-8 into UTF-8 view. Okay, so wait. Can it? Yeah. Okay, now it actually works. The inspector. Okay, so now it compiled while that was still cached. So let's compile again. Yeah, my hard drive is not very fast. Okay. So we still have that bug where for some reason this is not returning a U32. Well, we'll figure that out in a minute. Yeah. All that. Heavy value inspector. Maximize. Yeah, so this is invalid. This is UTF-8. Now ASCII is not liking that. Oh, okay. Space B. Let's see if it freaks out with a backslash. No, it doesn't. Okay. So I think that's sort of working, but in these cases it shouldn't. Like UTF-8 shouldn't be telling me. Okay. Yeah, ASCII is always telling me that it's one symbol. So let's actually go with like the Ö here. If I click that now, it dies because that's not an int 32. Yeah, and we figured out that that was when we looked at the size here. I32 custom. So if it's valid, then we should return the length here, which is a size T. What does ASU32 do anyways? Okay, so it doesn't even convert. Like they all need to be I32s. Let's actually do that a bit nicer. Or maybe that's just a programming error actually. To integer. No. Okay, so that's actually, I think that's actually an issue with HexEditor widget. Because like, yeah, why shouldn't, yeah. So we would want to integer size T. Like what? Why anything else? Because now we can do this and we can verify that that's smaller than whatever, and like, yeah, just check to int whatever. Yeah, this should also probably use more proper templates here, and maybe verify against. No, yeah, that should verify against the integer limit, not against int64 and 30. Oh god. Okay. And this is, yeah, no, this is written as though they actually meant integer here, like int. Integer as in int. I want to rewrite this function so badly. because it will blow up in your face probably if you don't put integer in there, or like very easily. Let's do that. And actually integral in here, so static cast t as u64, and that, yeah, so these as will verify the type, so that's fine. So do numeric limits t max numeric limits t max. Yeah, okay. I think we want to do that for all of them, even for i64. And now this creates some repetition here. Maybe we want to macroify that. Yeah, let's do that. Let's have bool float special case, of course, and string, bool float string special case. So so let's have if is type, then have this verify as type limits t max, return static cast t as type, and this needs some backslashes. Okay, so define that down here. Let's rip out all of these, Okay. Now we want to have 32. Come on. Is that double hash? I can never remember. Is that double hash? Yeah, that's double hash. Okay. So basically this allows you to like concatenate this first part of an identifier with this identifier taken from the macro parameter. And single hash, I think, just puts string quotes around it or something. So that's not what we want. Yeah. So let's handle u64, i64, and u64. Yeah, so, and that of course would not compile if these functions didn't exist. Okay, I just rewrote that into an arguably more beautiful form. It's definitely a more correct form. So we're gonna use that here. Actually, I'm gonna just commit those things now. Okay, so variant. What is it? Come on, Clang format. You can do this. Okay, that was a formatting error from earlier. Did you change anything else? No. Like GUI variant is something that we're trying to get rid of. I don't know. At least Ali wanted to get rid of it. I absolutely support that. So yeah, it's like it's very old code. Before we had like AK variants. Okay. libgui. Improve variant as integer correctness. Because this is a template already, it should correctly handle all integral types, including bounds checking. Actually, in that case, I think I forgot to check the lower bound. Yeah, okay. I forgot to check the lower bound. The function was internally still assuming int as the return type and relying on implicit conversions done by the compiler. That's not an idea. So let's fix it. Okay, so I'll have to, I can do the commit and then actually let's put in a check for min as well. Comparison of integers of different signs. In variant down here. Yeah, okay. So okay, so the right type is I32. This is I32's minimum, which is negative 2 to the negative 31. And the left one is... Okay, so I think I need to... Oh damn it, that's more complicated. So I need to check if the left type is signed and the right type is unsigned, other way around. If the left type is unsigned and the right type is signed, right type is signed, U32, then I don't need to do that comparison. So if const expr is signed type and if the left and is unsigned t, other way around, if the left type is, wait, okay, I think that way should work. Let's actually compile that. It's in the variant header. Yeah, that's, of course, it's template. So though most users are actually in this file. Okay. No. Comparison of integers of different types, which is we get the exact opposite problem. So I think we need that once again. We need so if the lower type is unsigned and the upper type is signed, let's see if that fixes it. I can't even get these things. Like this is some next level compile time programming. It's a macro, and within that, if const expr. I love it. It's amazing. It will generate a lot of very efficient code if I can get my damn parameters correct. This is the greater than or equals to comparison. Yeah, so that wasn't correct. So if the type is signed, and t is also signed, because if the type is signed and t is unsigned, then that would fail always. Wait. Oh my god. I am too dumb. So if the type is, I hate the terms signed and unsigned because it confuses me to no end. So if the type is signed, then we only want to compare its minimum if... Okay, so if the type is signed and the other type is also unsigned, we can do the comparison. Else, we want to verify that S type is greater than or equal to 0, because then that means that oops. That would mean that the type is yeah, so if it's signed... Okay, no. I need to nest this, so... Oh my god. So, this is a big tangent. Maybe I shouldn't have done this, but I'm already way too far into this. So if const expr... Remember, this is all free to some degree. It's free to some degree. So if we have a signed type, and then if t is also signed, we can actually just do the inverse down here, like just grab this. So if we have if const x, now if we have, so essentially we have 4 cases here. So signed and signed, we can compare that. We can just do their comparisons, actually both comparisons. Wait a minute. Actually both comparisons, like wait, no. There's a backslash missing here. So yeah, we need to we can paste that in here, which should give us Yeah, this is kind of annoying. Okay. So if we have a signed type on the left and an unsigned type on the right, I think we can still do the max comparison in either case. Expected name or blah, blah, blah. What the hell? Oh, I need to... no, this got screwed up again. Yeah, okay, so... So if we have a signed type on the left and an unsigned type on the right, then we need to wait. No, if we have an unsigned type on the left and a signed type on the right, we can actually, we have to check. We actually can do that less than comparison in either case, can't we? If with identical if and else branches. That just happens because of the const expert generation. Like, yeah, const expert will... So, or am I getting this wrong? So if we have an unsigned type, then that's larger. Maybe larger than the signed type. Okay, so I think I need to just... So if we have an unsigned type, we need to check if that fits within the limits of the other type. Wait, can I just... No, I can't do that because comparison integers of different signs. Let's compile that actually, so that I can see the actual line of the failure. That is in macro 168. Yeah, verify that I am larger than the minimum, and that's comparing U64 greater than whatever. So yeah, so if I have on the left side an unsigned type, then its minimum is always 0. So we don't even need the check. Yeah, because it doesn't matter. Either the minimum is the same or it's much lower. So it will always be true. So actually we need less checks if we have an unsigned type on the left. I think we're good now. Oh my god, this is so mind-boggling. This will compile down to very, very little code. Fuck my life. Okay. 166. So now we're complaining that int less than or equal to long unsigned length. It's not gonna let me do like shit, is it? Okay, so yeah, so if the I don't want to cast, like I don't want to cast, but at the same time I just want the check to execute. So if, yeah, so we already verified that we're larger than the minimum. we have a signed type on the left side and maybe and either type on the right side. So let's just cast that to the largest primitive type. Let's just fucking do that. Okay. So wait, I can't have a to make the compiler shut up. I cannot put in a comment apparently, or wait. I think I can just put in a single line comment. I think that should work. Yeah. Okay. Yeah, so because we've already checked the lower limit. So if we're already failing the lower limit check, then we're already dying here. So I don't even know what a static cast does to a if a static cast to an unsigned type does to a signed value. I hope it just rounds that up to 0, because then this check is completely perfectly valid, because if we have a negative value, we compare it to some like large value maximum, and we round that negative value up to 0, 0 will still be less than that large value maximum. So yeah, I guess that compiles actually. I don't think we have any checks for this, but yeah, maybe we're doing not enough checks here, but beforehand we weren't doing any checks either, so honestly, I don't care. Okay. This is accessing the drive again. Yeah, okay. So git commit and no edit. Okay, now let's just commit this. Which HexEditor. Don't require the value inspectors value size to be the value inspector models value size to be I32. This is rather silly. I don't know. Let's not actually comment that. I think it's perfectly fine if we just yeah, I actually have that in the comments. Okay, so let's value inspector. Let's use the where's that? The sharp S, which gives me that gives me just one character. So it's not crashing anymore, which is good, but it's not actually. No, it's not correct. So where are we failing? Oh, I need to return the byte length, not length. Well, I think that's the simplest problem of all of the problems that I've fixed today. Okay, I've already been at this hour and 20 minutes. Interesting. Yeah, that was a kind of a distraction. I hope you learned something about if const expr and very pedantic compiler settings today, because I don't actually think that's like a default setting we use. That's like making the compiler extremely pedantic about stuff. Yeah. Okay. I think that works. Cool. If we now change something to something invalid, okay, fantastic. So ASCII, of course, like this is always 1. UTF-8, in turn, it will just return 0 because that's not a valid UTF-8 character. On the other hand, if we go to the air, that works. Cool. Cool. I already have a long video here, so let's commit ASCII first and then UTF-8. So I'll need to say yes, say no. That's a no. It's an edit. Not commit this line. That's also an edit. Don't commit these 2 lines. Don't commit this. Okay, what do we have committed? We have the ASCII handler. We have the ASCII here. We have ASCII here. We have ASCII here. Okay. HexEditor. Display the ASCII value. Add ASCII to the value inspector. This is kind of redundant, but probably easier to read than the ASCII column. Also, it seems appropriate after we add other character encodings. Yeah. Cool. And let's commit the ASCII stuff. Should just be this, and then we have UTF-8, sorry. Commit the UTF-8 stuff. Commit that. Parse add UTF-8 to the value inspector. No, period. Okay, cool. While I'm at it, this is a long episode, but let's go all the way. Okay, so yeah, let's fix that up. Okay, and now let's quickly add UTF-16, turn UTF-16, because we also have the UTF-16 view, so that should be rather simple. UTF-16 and case UTF-16. Let's copy paste that. the UTF-16 view, luckily. What is... How is that constructed? Oh, need UTF-8 to UTF-16. Because to UTF-8. No. Okay. Yeah, okay, of course that makes sense because internally all our stuff is UTF-8. UTF-8 to UTF-16. This thing. Oh wait, no. So yeah, actually, because the string we store here is still a UTF-8 string, but we previously set it with a like we reconverted it from parsing the actual hex editor contents as UTF-16. So yeah, so because of course these values are things like the integers in text format and so on. Now I need to figure out what that is called. It's probably length encode units, length encode points, data. Does that only have this length encode points? Length encode units, probably. But doesn't this have... Oh yeah, so it's length encode units, which is just code unit size times 2. Okay. Yeah, okay, and let's go into the HexEditor widget and go down to the, where's that? Set parse value, here we go. So UTF-16 view of the read-only bytes. Let's just grab all of that. Constructor doesn't exist because let me just quickly check the constructors. We need code units. Okay, so first of all, we need to check if we have a multiple of 6 bytes. Multiple of, okay, so if the byte read count modulus 2 0, then we do all of that smart stuff, and else we just value inspector model set parsed value inspector model value type UTF-8 UTF-16. This is actually like not showing up because for some reason we always have a single valid byte. I don't actually know why, but I'm not gonna concern myself with that right now. So this is U16, U16 const probably. It should take a span U16 span of U16. Yeah, okay, so read-only bytes. Oh, right, because read-only bytes is a span of U8 const. Yeah, okay. So let's just grab all of that code. Oops. It's valid code units now. I'm not super familiar with U16, UTF-16 terms, except for that its smallest unit is 2 bytes. So actually, let's set that. Validate exactly the same API. Cool. So we could UTF-16 view to UTF-8 and don't allow invalid because we validated that all of them are valid. Okay. Let's check if those. I'm actually kind of in a hurry right now, so let's just check if that works. Otherwise, I'm gonna have to leave you with this half-broken code. But I think we accomplished a bunch of things, not least of which is making variant have a better integer conversion function. Okay. So HexEditor. Yeah, view the value inspector, UTF-16. Okay, so none of this is valid. That's actually to be expected. Oh, this is valid UTF-16 apparently. 6C2E. Can I find a single thing that's valid? No. Okay, so yeah, UTF, even though it's invalid, it's selecting 2 bytes. Anyways. Actually, what if I... Oh, wait. We got a valid byte there. Oh, that's fun. Okay, so now, of course, the UTF-8 things I think are... Yeah, UTF-8 is completely fucked up. But... Yeah, so that is still buggy, so I didn't implement that correctly. So this should... Yeah, this should actually not be... What is that doing? Is that inverting the bits? 6-9. It's definitely not parsing 6-9 because 6-9 would be... Oh, okay, so it's... Yeah, it's reading... It's reading like 1 byte ahead or 1 byte behind, yeah. Oh, no, it's reading the next 4 bytes and then taking the last one, or is it? Or is it even reading 8 bytes? It might be reading 8 bytes. Oh, right, yeah, because that's 64 bits. Ah, okay, so it's... Yeah, so that's not entirely correct. But honestly, that's something. That's, yeah, maybe we need to look at how many bytes we actually read, or like... Still, we might want to like read the first code unit from the top. I don't know. Maybe just big endian doesn't make sense for that. Yeah. Yeah, okay. Anyways, I think that's all I wanted to do today. Let's quickly commit that. HexEditor, add UTF-16 to the value inspector. And I actually forgot to remove the comment. So let's quickly remove the fix me for that. Okay, and with that, thank you very much for watching. this little adventure into mostly just code points and byte manipulation and multi-level code generation. Until next time, goodbye.